Lesson 5. Welcome with me at this lesson. The topic of this lesson going to be all about triangles. So very important, we are playing today with triangles. Now there are two parts or two groups of triangles I would like to look at. The first one is about classify about the lengths. And then yes, the second group that we're going to do a little bit later is about the size of the angles. Let's first look at the lengths of the sides in this case. The first one I would like to do, let's call it number 1. The first one is the scalene. Now if this is the scalene here, all sides are different and interior angles. That means that that side, and that side, all the sides got different lengths. And yes, then also with that then included, then I know that that angle, and that interior angle, all the angles going to be different sizes in that case. So the first one, the scalene, that we do know about the lengths. The second one I would like to look at, the isosceles triangle. Now this isosceles triangle do get to be known by two sides to be equal. And then of course with that together their base angles must be the same value. So two sides must be the same and two base angles to be the same. Then if I look at the third one, the equilateral triangle, that means that all the sides got to be the same. And then very important that all the angles, interior of course, are the same. And nice to know is that the interior angle value is then equal to 60 degrees. All of them equal individually 60 degrees. At a later stage I will show and prove to you how they get to the 60 degrees. So first one that we are looking at is the lengths, the triangles classified by the lengths, the scalene triangle, all three sides different lengths. Isosceles triangle, two sides to be the same. An equilateral triangle, all three sides to be the same. Now guys, what I would like you to do, you got to take this information and you need to write everything as I have it now. You got to show it for me in your classwork books, please. So when we can to work with it, that we can refer every time back to it. Now for the second group of triangles, and you can see classified according to their interior angles. Now the first kind I would like to look at is going to be the acute triangle or the acute angles. Now first of all, that we have to know that it is smaller. Acute means smaller than 90 degrees. So if I'm going to go and I make my axis down there, where this one is going to act as the 0 degrees, that one going to act as the 90 degrees. You can see that the angle is smaller than 90 degrees. And if I'm going to say, for example, this guy going to be something like 50 degrees, and I say that this one also, remember, smaller than 90 degrees, that one, for example, to be equal to 60 degrees, then that value down there must be then equals to 70 degrees. Because I have to start remember now that one of the facts, one of the properties of a triangle is, one of the triangle properties, let's just say triangle, the properties is that, and now look carefully, that the sum of the angles interior of a triangle equals to be 180 degrees. Now guys, this one is very, very important to start remember that one. The sum of the interior angles of a triangle equals to be 180 degrees. Let's put a cloud effect around it, so important that one is. So acute, smaller than 90 degrees, all three interior angles. The second kind I would like to look at is what we call the right angle. Now the symbol that we apply in the triangle is that symbol there, and that symbol there means one of the angles have to be 90 degrees. And when we see that appearing in a triangle, then we call or refer to that triangle as a right angle triangle. Then the third kind I would like to look at is the obtuse angle. Now what is the meaning of obtuse? We know that obtuse means it lies between 90 degrees and 180. So if I'm going to make my axis there again, you will see now that the angle interior 1, not 2, only one of the angles going to be bigger, greater than 90 degrees, but smaller than 180 degrees. So if I'm going to make that one there to be 120. Let me see if I can get another color there. 120 degrees down there. 120, and then let's say, for example, that one must be then 20 degrees, so therefore that one must be then also 40 degrees. Also take note, the rule in a triangle still stays. The sum of the angles interior of a triangle equals to be 180 degrees. And by the way, that same statement is also applicable on the right triangle down there. Guys, all these information again, I do need you to write it for me on your or in your exercise book. Very important that we can refer back to it later on. Right guys, let's look now at one of the examples. Let's call it first example 1. And let's see if we can use the previous information concerning the properties of the two triangles that we have done, the two kinds, and see if we can find some answers. So therefore I would like to start by filling some information in on the diagram. So let's call this to be angle A, angle B, and then angle C, referring to the triangle. And let's say for given information, they gave me that angle size there equal to be 80 degrees, and let's say for example that angle size there to be equal to be 50 degrees. And they come and they ask me, but what will that value of that angle be if I call it x? Now to do this kind of work, there's a certain pattern that we need to do. And very important, we must always use this block diagram where we first say you have to make a statement. So we always write in the first one, statement. And then if we have made a statement, if we have say something, then you have to back it up. Why? So we say there, reason. So these two things are always very important. Statement, reason. And we're going to use this really many times in the explanation and in this kind of calculation. So right, let's say, remember we have said that the interior, the sum of all triangles, the sum of all interior triangles equals to 180 degrees. So I'm going to make a statement. I'm going to use the property of the triangle where I'm going to say that angle A plus angle B plus angle C. Now guys, that is the symbol if I refer to the angle. Angle C must be equal to be 180 degrees. That's one of the facts, one of the properties of a triangle, that the interior angles are equals to 180. Now the reason, remember that reason, the sum of the angles interior of a triangle equals to be 180 degrees. Very important that we do write it like that. Now I'm going to substitute. What is the value of A? The value of A in this case is going to become 80, and guys, that symbol, the degree symbol, very, very important. We need to show the degree symbol all the time. Plus, what is the value of B? Angle B, interior of B, is going to become equals to 50 degrees. Plus the one I would like to determine. The X is referring to the angle C, so it's going to become X must be equal then to 180 degrees. So therefore I'm going to say that 80 plus the 50 is going to give me something like 130 degrees plus the X equals to be 180 degrees. Then I'm going to take the 130 degrees to the right hand side, where I'm going to have then X must be then equals to 180 degrees minus the 130 degrees. And if I subtract that, then it's quite clear that X going to give me a value then of 50 degrees in that particular case. And that was not too difficult to do that, especially if I remember the fact where we can say that the sum of the angles interior, the property of a triangle, equals to be 180 degrees. So this part, this beginning of the part was really, really very important for me to start with that one down there. Let's go for another example. Right guys, now for example 2. Now let's first start to label the triangle again. This time we can see that it's an obtuse triangle. How do I know for obtuse? That one of the interior angles is greater than 90 degrees but smaller than 180. So I'm going to say call that one angle to be A, that one to be B, and that one to be C. It doesn't matter that you have it in this pattern, ABC. You can put the B and the C, it doesn't matter where you put it as long as the angles are labeled. What do we do inside the triangle? We're going to call it always to be statement. And this one to be reason. Let's put some information down on our sketch that we can work with it. Let's say given information. That angle there to be 31 degrees. And let's say that the obtuse angle is given to be 112. And let's say again they want me to determine the angle C in that particular case. What do we do first? We start with one of the properties of the triangle, the sum of the interior angles of a triangle. Right, so we're going to say angle A, plus angle B, plus angle C must be equal to be 180 degrees. And my reason, remember, the angle, the sum of the angles interior of a triangle equals to be 180 degrees. Now I'm going to substitute the angle of A to be 31. And don't forget the degree sign, plus angle B to be 112 degrees, plus angle C, the wanted one that I have to determine, X equals to be 180 degrees. On the left, if I add 31, 112, going to give me something like 143 degrees, plus the X must be equal then to be 180 180 degrees, the property of a triangle. So therefore, take the 143 degrees over. I'm going to have x going to give me then 180 degrees minus the 143 degrees. And that's going to leave me with the answer x to be something like 37 degrees for this calculation. Let's go for another one. Now for example number 3, let's write it. Example number 3. Let's come this time again, and yeah, I think let's call it again angle A, angle B, and angle C. But this time I'm going to give a little bit of other information on the diagram. Where, for example, I'm going to solve. Let's call this one, that angle this time to be 110 degrees. And I'm going to come in this information for this diagram. I'm going to say that I have two sides to be the same. Immediately, that I do know is that if the two sides are the same, what kind of a triangle am I referring to here? It must be an isosceles triangle. So let's start. I'm going to say statement and my reason. Again, I'm going to start by saying, yes, I do know the property of a triangle. I'm going to say, and let's call this one, I forgot to call this one to be x in that particular case given to me. So here we're going to start. I'm going to say that angle A plus angle B is plus angle C is equal to be 180 degrees. So therefore the statement made, and the reason for that again is the sum of the angles interior of a triangle equals to be 180 degrees. But now I'm going to look at this one, and I look really at the one where they say angle X, C. Oh, but wait a minute, I see that it's an isosceles triangle. And what do I know? I do know from previous experience in the rules that the base angles of a triangle also have to be the same. So therefore that angle also got to be the same in that particular case. So now we're going to say but angle B must be equal to angle C must be equal to x. Now the reason that we're going to do here is we're going to say that the angles opposite, and we're just going to say opposite equal sides. And this one is important. We do not refer to the base angles. We refer this time that the angles opposite are equal sides in this particular case. So I'm referring to the angles. So the sides are given to me to be equal. So it's the angles opposite equal sides. Very important, that one. So I do not refer to the base angles. Now I'm going to substitute all this case. So I'm going to say angle A is 110 degrees plus B now is x. Angle C, oh I forgot the angle there, plus angle C equals x equals to be 180 degrees. So therefore I'm going to have 110 degrees plus 2x equals to be 180 degrees. So I take the 110 degrees across. I'm going to end up with 2x equals to be 180 degrees minus 110 degrees. And now I'm going to have 2x going to give me a value something like 70 degrees in that particular case. Now I'm going to say on the left, if I divide with a 2 on the left so that they can cancel, I must also divide with a 2 on the right. So therefore it looks to me that my x answer now here going to become equals to 35 degrees. And guys, this answer is also equal to angle A equal to angle C in this regard. Right guys, now it's your chance to show me how it must be done. Let's call it homework. I want you to call this angle A, this angle B, this angle C. And if I'm going to give you the information, this one here, the angle A to be 23 degrees. I'm going to give you angle B to be 134 degrees. And I'm going to call this angle here to be X. Which one of the three examples are you going to use if I'm going to ask you determine the value x to be equal to? What example are you going to do? I want you to select one of the three examples, and according to the example I really want you to have a good look, and I want you to see if you can find the answer for me. Please, all the best guys, have fun. We will only have one calculation because it's a total new topic we are dealing with here, and also you have to prepare for the test coming up, and let's see how you're going to perform on the test in this regard. Guys, all the best, have fun, and have faith. Thank you very much.